Howdy, howdy, folks. Welcome back. And since we've already made a couple of videos which show you a little bit about the Linux file system, I thought I'd follow that up by making a video about the subject of links. There are two types of links. We have symbolic links and we also have hard links. So what's the difference? Well, a symbolic link is a file that points to either another file or to another directory. And so here, for example, we are in the dev directory, and we know that we're looking at links because we have the L at the beginning of each one of these lines. And we can see that we have a symbolic link named CD-ROM, which points to this SR0 device file. And the same thing all the way down. Core points to a file down in the proc file system, and the rest of them there are pretty much the same way. Okay, so with your symbolic links, they are a file that can point to either another file or to a directory, either one. On Red Hat style operating systems, such as this CentOS 7 machine, we're in the etc directory, and we see something that is generally not seen on other Linux distros, and that's the fact that we have some built-in symbolic links that point to other directories. So here we can see that the init.d symbolic link points to this init.d directory that's within the rc.d subdirectory. So because of that, I can either do cd etc init.d, or I can do cd etc rc.d init.d. Either one, they both get me to the same place. Okay, so how do we make a symbolic link? Well, to demo that, I'm going to work with this Debian virtual machine because it is a brand new virtual machine which has a completely clutter-free home directory. So that'll make things a lot easier to work with. So the first thing I'm going to do is I'm going to make a link demo subdirectory here within my home directory. So you see that's there. And then I'm going to create a dummy file. I'm just going to call it donnyfile.txt. And you see that it is right there. And then I'm going to make a link to it. And to do that, I'm going to use the ln utility. To make it a symbolic link, I'm going to use the -s option switch. And then I'm going to do home donnyfile.txt. And notice there I am listing the entire path because the ln utility tends to not be able to find files unless you do that. So that is the file that I'm linking to. And then I'm going to designate the name of the symbolic link. So, and I'm going to make that in that link demo directory. And I am making it the same name as the original file. But again, I do not have to do that. I could make it a completely different name if I wanted to. So now we can go into that link demo directory. And we see that we have our symbolic link there that points back to that original file. Now let's add some text to that file. But let's go into the link demo directory. And let's add that line of text via the symbolic link. And we'll save that. And we see it's still there. Let's go ahead here and go back out here. let's open this up. Okay, so we see that when we go back to the original file, that line of text that I added via the symbolic link is still there. So let's add another line of text. We'll save that. Go back into the link demo directory. And we see that that line that I added via the original file is there. So it doesn't matter whether I access or edit this file via the original file or via the symbolic link. Now what happens if I go out here to my home directory, to the top level of my home directory, and delete that original file? Well, we see that the symbolic link is still there in that link demo subdirectory, but it is now broken. It does not point to anything anymore. And if I try to open it up, you'll see it's just like opening up a blank file. Now, if that ever happens in real life, that's no problem. All you have to do is remove that symbolic link with the RM utility, just the same way as you'd remove any regular file. And that's all there is to it. Next, let's talk about hard links. Hard links do pretty much the same job as symbolic links in that they allow you to access files from different locations, but there are some differences. So hard links, to begin with, are not separate files. Instead, there are just entries in the file system index table that can point to a certain file. As we're going to see in just a few moments, any given file can have multiple hard links pointing to it. Hard links, unlike symbolic links, can only point to files. They cannot point to directories. Also, unlike symbolic links, hard links can only point to files that are on the same partition. So you can't have a hard link on one partition pointing to a file on another partition. But the way in which hard links are the same as symbolic links is that they can have either the same name as the original file or they can have a different name. So let's take a look at that and see how that works. So in order to understand the concept of hard links, you have to understand the concept of inodes. Now, an inode is the basic structure of a Linux file system that contains the information about a file. So an inode is going to contain the contents of the file, the characteristics of the file, time and date of last modification, time of date of last access, permissions values, all of that stuff, okay? So really, the inode is going to contain all information about a file except for the file name. The file name is over here in the file system index table. So when you create a file, there's already going to be a hard link that points to it. So every file on the file system will already automatically have one hard link. So let's say I come over here and I create my donnyfile.txt. Okay. That is a hard link that goes in the file system index table, which will point to, once I get my brush back up here, there we go, that is going to point to this inode. Now, I can also come over here, if I wanted to, and create another hard link that points to that same inode or to that same file, whichever way you want to look at it. So I can come over here and I can say, for example, link demo.donnyfile.txt, and this time I'm going to reduce the size of my brush a little bit. There we go. So we can have that one pointing back to this same inode and to that same file. And then if I wanted to, I could create another hard link, and I could have it with a completely different name. So for example, I could say link demo myfile.txt. And then have that pointing to that same file as well. Okay? Now, when you go into your terminal window and do an ls-l command, it may look as if you have 3 different files here, but you actually don't. It's all just one file, but you have 3 different hard links pointing to that file. Okay, so back here on the Debian machine, let's go ahead and create this donnyfile.txt again. And if we do an ls-l on it, actually, let's just do it on the file itself. We see here in this column a number 1. That means that we have one hard link that points to that particular inode that contains this file. So to create a hard link, we're going to do that the exact same way as we created a symbolic link, with only one difference. We are just going to do the same command, except that we are going to leave out that -s option switch. So now if I do an ls-l on that file, you see that I now have 2 hard links. If I go into the link demo directory, you see I have the hard link for there as well, also showing 2 hard links. Now, as I said before, this looks like we have 2 different files here, but we don't. It's still just one file, just 2 different ways to access it. So I could, while I'm in this link demo directory, I could open this up in Vim. And I'll save it. And I'll go back out here. Okay, and you can see now that the time of last modification is different from what we had up here when I first created that file. And I can open this up. And there we have it. That line that I added via that second symbolic link is there. And I could just go ahead then and do this. And I could go into link demo again. And you see that that line that I just added via the original hard link is still there when I access the file via the second hard link. So now let's try this again, except this time we're going to add a hard link of another name. So let's just call it myfile.txt, like so. And this time you see that our link count has increased to 3. So now we have 3 hard links that point to that same inode. So 3 different ways to access this file. We go into link demo. We see here that we have the donnyfile.txt hard link still and the myfile.txt hard link, and each of them shows 3 different hard links. So I could open this myfile hard link, and look, that line, well, both the lines that I added via the first 2 hard links are there. And now we can do an ls-l, and notice that the time and date of last modification is the same on both of those 2 hard links. And if I go back out here, time and date of last modification there is also the same. And regardless of which one of these hard links I use to open that file, the contents will be identical in all of them. So again, it's just one file. And I keep emphasizing that because this is a concept that's sometimes hard for my students to wrap their heads around. So I just got to emphasize, this is one file. This is not 3 separate files. This is just one file, but I have created 3 different ways to access it. Now, what if I want to find all of the hard links that belong to a file? Well, to do that, I can do the find utility, and normally you'd probably want to search for the entire file system, but I'm not going to do that now. Instead, I'm just going to search through the current working directory, and the find utility is inherently recursive, so it's automatically going to drill down into the subdirectories for me. So I'm going to do find dash same file, Donny file, like so. And there we have it. It has found all of the files, well, excuse me, it has found all of the hard links that are associated with that one file. And if I wanted to, I could also do a dash ls, and that does a long listing for me. And now what happens if I start deleting these hard links? Well, first let's go into the link demo directory, and let's delete that donnyfile.txt. So the myfile.txt hard link is still there, and the contents are still intact. So let's go back out to the top level home directory. And we see that the donnyfile.txt hard link is still there, the original one. And also I forgot to point out that the hard link count has decreased to 2. And so now let's go ahead and delete this original hard link. Okay, not there. We go into the link demo directory. Myfile.txt is still there. The hard link count has decreased to 1. I open that up. The contents are still intact. So when you delete a file, or when you want to delete a file that has multiple hard links pointing to it, the only way you're going to remove that file is to remove all hard links that point to that file. Okay, so that's really all there is to it. And something I forgot to mention too is that these hard links, the symbolic links, work wherever you have a bash shell. So they will work on all Linux distros. They will work on Mac OS X, on BSD, Open Indiana, Unix, anywhere that you have a bash shell. These symbolic links and hard link commands are going to work exactly the same way. Okay? So anyway, I do hope that you enjoyed this. And if you did, and if you like it, be sure to like and subscribe. And we will see you next time.